So today we're going to talk a little bit about a new topic, which is really scatter plots, correlation, and line of best fit. Really, the goal at the end of this week and next week will be able to talk a lot about a line of best fit. So we're going to start with this first word here, and it's called correlation. You're going to hear us talk about correlation a lot, and correlation really just means a relationship between data values, and you can actually see that word relationship almost in the word correlation, right? So correlation is really just a relationship between data values. Right? It's really just a relationship. They show some kind of relationship. We're going to talk about really two different types of relationship at the start here. Well, really three: positive, negative, or no correlation. So these first two scatter plots at the top show a positive correlation. That means as the one value, as the x value gets bigger, so as you move your way along, right, the x-axis here, you'll notice the y values also increase or get bigger. Same thing in the second example. You move your way along the x-axis from left to right, right? The y values are also getting bigger. The other big thing to note there, it's just like slope really. A positive correlation looks like it's going up from left to right. Right? Just like in slope, positive slope goes up from left to right, positive correlation goes up from left to right. The same thing is true of negative correlation. These two scatter plots down below here, if you want to compare them to the top, show negative correlation. As the x value increases, or as you go from left to right along the x-axis, the y values are going down, right, or decreasing. And again, just like slope, with a negative slope, it goes down as you look at it from left to right. These negative correlation scatter plots really go down as you look at them from left to right. So that's positive correlation, negative correlation. You can also really have technically no correlation. If I was going to sketch it out, no correlation could look something like this. It's really where there's your x and y axis, really where you have points like all over the place. There really just is no relationship. It's just a bunch of points in a scatter plot. So that's sort of like a no correlation there. Right? Now, once we decide if like a scatter plot has positive or negative correlation, we can also talk about whether it appears to be linear or nonlinear. These two, again, if you think about that word linear versus nonlinear, look at the word. Linear has the word line in it. That's a word that we've seen before. It means the data has a relationship and the relationship appears to be a line. Right? Again, in these ones, these points appear to sort of, it's not a very good line, but they appear to form a straight line. Here, they sort of appear to form a line. Whereas these points are not very linear. They're sort of like more of a curve to them. Here there's a definite curve. So that's sort of linear versus non-linear relationships. That's not going to be a huge emphasis, so that's not something that we're going to spend a lot of time with right now, but it is something that you will talk a lot about in future math classes, whether the relationship in the data is linear, meaning it looks like it's forming a line, or it's non-linear. Right? So when our data appears to be forming a line or appears to have a linear relationship, right, we can create something called a line of best fit. And this is really our goal for today. So let's look at this example here, and we'll kind of talk a little bit about that line of best fit. So it says Sabrina's planning a birthday party. She collected information. Here's the scatter plot. Right? You can read that there. So I created a scatter plot of that table. Right? Now, the first thing I want to talk about, and maybe this would be a good time to pause your video, is does the data appear to form a line? So is it linear? So maybe pause it for a second, answer that. And so I would say that yes, this data is linear. Right? It looks like it's forming a line. And then again, this would be another good time to pause after this question. Does the correlation or relationship appear to be positive or negative? And so maybe pause. And I would say that this data appears to show a positive correlation because again, it's going up, right? As the X value number of guests increase, the cost of the party is also increasing. Positive relationship, positive correlation, right? So for these scenarios, what we can do is where they show a linear relationship, they're not all on the same line. We can draw what's called a line of best fit that really represents the data. The line of best fit, and I'm going to scroll down here so you can see this. It's a straight line that best represents the data and can be used to make predictions. So a line of best fit is really, again, here is a line that you can use to represent a set of data that's not all falling exactly in line. And you can use that line to then make predictions about future occurrences. So if you look at this scatter plot we have here about the party, it does appear to be linear, but they're not all lining up in a straight line. Again, if I'm going to grab like my line tool, right? I can even put my ruler on here for a second. This is going to be kind of awkward to see in the video. There's no one line. If you look at me lining my ruler, there's no one line I could draw that would exactly connect all those points. But the data does show a linear relationship. It does appear to be lining up. So what I can do is draw a line of best fit, or really a line that's going to best represent the data that I can use to make predictions at. Okay. So let's talk a few minutes about the line of best fit as I grab my ruler. Right? One of the first things I want to point out, and this is a key, the line of best fit does not have to touch any of the actual data points. Right? So let's start here. Let me draw this first line. Is that a good representation of the data? So maybe, again, you're looking. Hopefully you're thinking to yourself, that is not a good line of best fit. That line does not represent the pattern of the data, right? It's far too flat in comparison to the data. Right? So let's say we grab our ruler again and draw another line of best fit. Right? Let's say I draw this line of best fit. Now ask yourself again, does that look like a good representation of the data? And hopefully again, you're thinking, no, that doesn't even have the right type of slope, or in this case, correlation. That line shows a negative slope or negative correlation. This data does not have negative correlation. That line does not line up anywhere close to the data. Okay? So if I grab my ruler again, right, I'm going to sketch in what I think is a pretty good line of best fit. As you're trying to decide where your line of best fit is, one of the things that you'll notice is there's never one exact answer, right? So I sketched in this line in red there. Right? You'll notice this is a pretty good line of best fit for a number of reasons. There's about the same number of points above the line as below the line. It follows the trend of the data well, so it represents the data well. It's kind of right in the middle of all the data, as close to the data points as it can be. The other big thing you'll notice is it does not actually touch any of the data points or any of the points on the scatter plot. That will absolutely happen. Sometimes you might draw a line that does go through some of the points, and that's okay, but your line of best fit does not have to go through any of the data points. I'm actually going to write that note here because that's a big thing that a lot of people sometimes try and do. Your line of best fit does not have to touch any of the actual points, meaning on your scatter plot. A lot of people always think it has to. It does not. Remember, you want a line that is a good representation of your data. And so that line I drew is like right there in and among the data. It's a great representation because it's following the trend or the pattern of the data, right? And it's representing it really well. Now, what we're going to do here in our last example or two is use a line that's already drawn, right, to determine or make some predictions, right? That's our final step for today. So it says the scatter plot below compares the time teenagers spend on the computers and the time spent watching TV. The scatter plot also shows a line of best fit for the data. So that's the one I drew in red there. Again, you'll notice, right, maybe this is a good time after I ask these two questions or one question to pause. First, what type of correlation is shown? that should make sense because as the time someone spends on the computer increases, the time they're spending watching TV would decrease. And you'll notice that line again is a good line of best fit because it follows the trend or the pattern of the data well, right? About the same number of points above and below, follows sort of the same slope of the data. So it's a good representation of the data. Right, so it says based on that line of best fit, about how much time does a teenager spend watching TV if they spend 90 minutes on the computer? So what you really want to do here is find 90 minutes on the computer. And you'll notice it's kind of a line in between. So it's right here, it's this line. And you want to kind of trace that up to where, right, it hits the line of best fit. And to me, it looks like that's going to be, right, there's the 150 because they're counting by 30s on each axis. It looks like that number should be somewhere between then that line of best fit. You can even zoom here a little if you need to, between 150 and 180. So if I look at my choices, the only choice that's between about 150 and 180 is choice D, 165. Notice 200 and 240 are way too large. That would be like up here somewhere, those points. So they're way too far above the line, so that's not good. And the 140 would be way too low. That would be down here somewhere below the line. So that's the best choice. And then the second question says, let me erase some of my markings from the first. Based on the line of best fit, if they spend 60 minutes watching TV, about how much time do they spend on the computer? Now you just want to be careful with your labels here. If it's 60 minutes on TV, that's on the y-axis now. So that's right here. Trace it over to your line of best fit. It's right there. So it looks like a good estimation if I see how much time that's on the computer. If I look down at time on the computer then, looks like a good estimation there would be about 300 minutes. That looks great. So we're going to do the same thing in this last example. This is our last one. Thanks for sticking with me. I know this is a little longer, but we're getting to some new stuff now. So it says the scatter plot below represents the relationship between temperature and ice cream store's money made. Use it to answer the question, right? Right, so in this last one, right? Right, so we look at this scatter plot and we can see we're asked to find, right? Or maybe I'll start first, same question, you're going to pause. What type of correlation? And hopefully you said positive, because again, as the temperature increases, the sales at the ice cream store is increasing, right? Or again, it looks like it has a positive slope. What would be a good prediction for the money made if the temperature is 21 degrees Celsius? So I'm going to find 21 on the temperature axis, which is the x-axis. It's right in between here. So I'm going to look there. I'm going to trace up. Looks like it's right around there. So if I'm, again, making an estimation, your number does not have to match mine exactly. I would say that looks like maybe roughly $475, between 400 and 500. Definitely a little closer to the 500, so I'd say about 475. If you had anything in the range, I'd say of like, I don't know, 460 up to like maybe 490, all good estimations if you tried this before me. Should definitely be a little smaller than 500, definitely probably I'd say bigger than like 450. So somewhere in there is good. Okay. So that is scatter plots, correlation, and line of best fit, just our introduction. Next week, we'll look at how we actually draw our own line. So next week, I'll have you draw your own line, write your own equations. But for today, we just focused on identifying the correlation or relationship and using a line of best fit to make some predictions.